Hello, class. This is Mr. Hart, and in this podcast, we want to continue with the radiation chapter of our textbook. And in the last podcast, we looked at how radiation works and some of the types of radiation. In this podcast, we want to look at the different uses and some of the dangers of radiation. Okay, but to start off, one of the first uses of radiation is actually in geology, and it's called carbon dating or radiometric dating. And so, what they do is when they find a fossil or a rock structure like this, they can actually take out a small chunk of the material within that rock structure, and they can actually find out how much of it is radioactive. And based on the amount of radioactive material, they can actually figure out how old the fossil is, which sounds crazy, but it actually works really, really well. Just based on how old it is, the less amount of radioactive material you expect. So the longer it's been, the less radiation you're going to see. If it's a really young fossil, you'll see a lot of radiation. If it's a really old fossil, you'll see a very small amount of radiation. And so they use the radiation as a measurement of the age, which is really, really cool and a very, very common use for radiation, this radiometric dating. So, again, very useful in the field of geology. There's also many uses in the medical field. Okay, a lot of machines, um, like the MRIs and CAT scans and other devices, often use radiation. Okay, they will detect radiation coming from your body, or they'll use radiation to measure certain parts. X-rays use X-rays, which are radiation. Okay, and that you can just look at the different ways the radiation is rebounding off materials and reflecting and being absorbed. And based on those things, you can get a lot of information out about a person's body, which can be very helpful for diagnosing problems. And they also use it for chemotherapy and things like that, right? Trying to kill very specific parts of the cells, right, that are cancerous. And so they can eliminate those by using radiation. And so usually the quantity of radiation that you see is very, very small. Okay, so you often don't have to worry about any type of damage or adverse effects from the radiation because it's usually very small quantities. The only one that really is kind of controversial is chemotherapy, because you may have a cell, for example, a cell that's sitting right here. You send in radiation and it kills the cell, which is great. But there's also another cell right here that wasn't cancerous. Well, guess what? That radiation is still going to go through and kill off that cell. So there's a lot of controversy sometimes with chemotherapy, because not only does it kill the bad cells, but it can also kill the good cells, and it can cause some other problems sometimes. So that's one that is continue trying to be improved and improved, so that they aren't killing the good cells, only killing the bad cells. But again, very, very useful in the medical field, and continuing to improve as time goes on. So radiation, again, very, very common for medical devices. And then one of the last ones, and probably one of the most fundamentally changing ones, is the using radiation as a power source, which is very, very cool. Gamma radiation, because it's an electromagnetic wave, it can actually be absorbed in the form of heat. And so what they do is they will put in a source like uranium, for example, and they can use that source of uranium to generate lots and lots of gamma radiation, and it will cause lots and lots of heat. You put water around the uranium or something like that, some type of liquid, and it absorbs this heat that's being generated from the uranium, and that heat can turn into steam, and that steam will turn a turbine, which generates electricity. And so these huge stacks, you probably have seen these giant, cones coming up into the sky from a nuclear fission plant. That's the steam kind of being released into the air, but a huge amount of energy that is being released. Yeah, if you look at a uranium pellet, okay, it's maybe no bigger than, a fingertip. It can store as much energy as 1 ton of coal, if I remember correctly. So this one chunk of, uranium will have the same amount of energy as a ton of coal, okay? That's pretty crazy if you think about, other ways to generate energy, burning coal and, solar energy and wind energy and all these other types of energy. They don't even come close to how much energy nuclear power can provide. And so For very, very large cities and metropolises, you'll see fission power plants because they can just provide so much energy. Okay. There are some adverse effects of these, though, but we'll talk about those in just a second. But those are kind of the three main uses I would note for radiation: the geological dating, the medical uses, and the power production from radiation. All very unique and useful applications of radiation. All right, so that's the uses. Let's get into some of the dangers. Okay, so you may have heard on news reports and things like that about health risks in class. We've talked about and watched this video about the different health risks that are presented with radiation. But let's look at a chart for the dangers of radiation. Okay, so if you are being exposed to radiation, there's a table based on how much radiation you're receiving, which we call REMS. Okay, your exposure in REMS. And again, this is usually gamma radiation because alpha radiation and beta radiation are stopped pretty easy. So this is your exposure in REMS to gamma radiation. So low exposures of about 5 to 10 REMS for a very long time can cause changes in your blood chemistry, which isn't usually a big deal, but maybe over a very long time can lead to other problems such as leukemia and other cancers of the blood and things like that. And so if it's only for a short time, though, probably not going to see any harm from that. Okay. If you're starting to see larger amounts, about 50 to the 70 range, and you have it for about a couple of hours, then you're going to see some nausea, you're going to see some fatigue, maybe even some vomiting. Okay. But that's a pretty large amount of radiation that is coming from a source. You want to just see that, on a regular sidewalk or something like that. This isn't just going to be by chance. You'd have to be going near a very radioactive source for a very long time, really. You couldn't just pass by it. So after hours to 50 to 70 rem exposure, you would see some nausea, some fatigue, some vomiting. Okay. In the higher amounts and over about a week's amount of time, you'll start to see things like hair loss, diarrhea, maybe even get some hemorrhages. Okay. So you're starting to see some very, very bad effects from the radiation. But again, this is a long amount of time. You're not going to see this if you only have it for a couple minutes. You need this exposure for a very long amount of time. And again, this is a very large quantity. Okay. Once you get to the 400 rem stage, you start to see the possibility of death from the radiation. If you have it for a long amount of time, 2 months, you might see some internal bleeding at 1,000 rems. And then within weeks or even days or even minutes, if you start to get things within the 2,000 rems, which is a huge amount of radiation, which is right next to the explosion of a nuclear bomb type thing, then you'll start to see your nervous system start to go out of whack. You'll lose consciousness and probably die within a couple minutes. So again, there's kind of two things you need to keep in mind: your exposure time, your exposure amount and your exposure time. They're both very important. Okay. Small amounts over a long period of time can have the same effect as large amounts over a short period of time. So anytime you see some type of radiation poisoning or hear about some type of radiation effect, you need to consider how much was the exposure and how long was it applied for. Okay, that's why some of these people that work in nuclear power plants or in other locations where they're concerned about radiation, it's not so much the exposure amount because it's usually very low, but it's the time. They work there every day for a couple of years. That radiation is eventually going to start to get to them. Okay. So keep this in mind. This is kind of just this isn't a perfect table, but it kind of gives you an idea of what type of effects you're going to see. And again, I'll just reemphasize exposure amount and your exposure time. Okay. And so if we look at the dangers of radiation by type, again, I think I said this in the last podcast, but alpha radiation is the most dangerous, can cause the most adverse effects because it's directly changing the chemistry in the objects, can cause mutations in the cells, but it's easily absorbed. Okay, so it's usually not a problem. It's easily blocked or shielded. Okay, beta particles are the next farthest traveling. Okay, they can cause electrical storms and can knock out power grids sometimes even, but again, generally speaking, not very dangerous. This gamma radiation is the one we usually focus on when we talk about REMS. Okay, It travels great distances. You can't really block it. Okay, it doesn't interact strongly with cells, so you may not even realize that you're being hit with it. But it's those long exposures and those large exposures that cause the illnesses we were looking at. Okay, so even though alpha really is the most dangerous, I consider gamma to be the most of the problem. Okay, it's going to cause the most problems for people health-wise. Okay, and so again, you go back here. All these numbers are for gamma radiation. Keep that in mind. All right, and so last thing to think about is the amount of distance. So if you think about like a nuclear bomb or a nuclear blast, this picture is for the actual bomb itself, the blast from the heat, but you can consider the same picture for the actual radiation as well. Okay, so for example, you'll see complete destruction with the 1 mile zone. You'll start to see less damage as you go further and further out from the blast. Likewise, you'd probably see a lot of alpha radiation close to the center of the explosion, but it's going to be absorbed fairly quickly. As you get a couple miles out, you'll start to see the beta radiation get absorbed. And then as you go further and further out, you'd see the gamma get weaker and weaker, but you'd see alpha, then beta, then gamma, kind of in these different distances. And keep in mind, again, for like alpha and beta, if you get hit by the blast, you probably get hit by those types of sources. But for everyone else that didn't get really hit by the blast, the gamma radiation is the main problem. Okay. And so again, gamma radiation won't stop. It will travel a good, 20 miles out before it is even absorbed by most of the stuff around it. And so if you ever hear of nuclear fallout or places of nuclear fallout, they'll close around a 25-mile perimeter just because of the gamma radiation. And a classic example of that was Chernobyl in Ukraine, or modern-day Ukraine. It was a nuclear power plant that had fallout, and the radiation, basically blew up, right? It causes all this radiation to be spewed out. Within the mile area, alpha radiation was a big problem, and the beta radiation. But after about a mile, it's not so much that stuff, it's the gamma radiation. They closed a 25-mile area that's uninhabitable for, the next 1,000 years or whatever it is. Okay, because of that gamma radiation, because anything in that zone still has the gamma radiation absorbed in it, so it could re-emit it at any time. Okay, so that's why you can't, collect materials from that area, especially metals. Metals are very good at absorbing radiation, and so you would want to, stay out of Chernobyl. Okay, if you lived in Ukraine, and again, the things I would keep in mind for the dangers of radiation and kind of how to prevent it is you want to limit your exposure amount. Okay. The quantity of the exposure is key. Okay. The less you can get, the less problems you're going to see. Another thing to keep in mind is the amount of time you're exposed. If you're only exposed for a few minutes, it's probably not a big deal. If you're exposed for a couple of days, that's when it starts to get to be a problem. And then your distance from the radiation source. So if you can get farther and farther away from the source, the better off you're going to be. So that's why, people aren't allowed 25 miles within Chernobyl, because you want to make sure you have a nice large distance from any type of radioactive material. Okay, so exposure, time, and distance. All right, but that is it for this week. We looked at the different uses and dangers of radiation. Hopefully that gives you a better understanding of what concerns there are for radiation, because there are some, but also what things aren't concerns, and what are myths and what are facts and those types of things. So hopefully it answered a lot of your questions about radiation and maybe some things you kind of have thought about as you've been growing up. I've learned about radiation, but hopefully that makes sense. Let me know if you have any questions, and thank you for watching.